Multiplication of rationals without mixed numbers. Now, this is the beginning of multiplication, and you will actually find that multiplication of rationals and division of rationals is easier than addition and subtraction of rationals. And I'm going to show you the very beginning of this, and we're going to do a question after you understand why certain things happen when you multiply fractions, and you'll see why I say it's easier. So let's have a look first of all at a very simple question. 1/2 times 1/4 is the very first question I'm going to ask you. Now, 1/2 times 1/4 can also be thought of or restated as 1/2 of 1/4. So if you did 1/2 of 1/4, let's go over to this circle. And you've got a quarter here. And if you take 1/2 of that, that'd be approximately all of this. That's your answer. Okay, well, if that's the answer, what is it? And because you have to put it as a number. Well, let's see what's happened. If you've got 1/2 of 1/4, that means that you have a half, 1, 2 in this quarter. You have to basically know what size this is. So how many of these could fit around the circle? And if you know how many of these could fit around the circle, then you know what the answer would be. So you've got 1, 2, 3, 4, 5, 6, 7, 8. Because there's 4 quarters and you have 2 in each, you have 2 times 4. So this is 1/12 because, 1/8, because there are 8. 2 times 4 is 8. So there is 1/8 would be one of these. 2 in each quarter, 2 times 4 is 1/8. That's the answer. So notice how you basically said for in each quarter, there are 2 of those. 2 times 4. Now, in this one, you've got 2/3 times 1/4. So 2/3 of 1/4. That means you're going to have to divide this into thirds. So you have your quarter again, and I'm going to try and make it a good thirds. They may be a bit off, but those are thirds, all right? So if you've got 2/3 of 1/4, well, that would be 2/3 of 1/4. Now, you want, instead of 2/3 of 1/4, you want to know, well, what size is that compared to a whole? Because that will say the proper size, and you can put a proper number to it. Well, in order to do that, you have to know how many of these pieces fit into a whole, and that will give you basically what size this is. Well, first of all, let's just take this and let's find out how many thirds there are. In each quarter, there are, how many thirds of quarters there are. So there's 3 in here, 3 in here, 3 in here, and 3 in here. So because you've got 4 quarters, you've got 3 times 4, which is 12. So each one of these are 12ths. And how many 12ths do you have? Well, you've got 2 12ths because you've got 2 of them. So notice you've got 12ths and you need 2 of them. So the answer is 2 12ths. Another way to talk about that is you can say that this is actually 1/6 because you have 6 of these 2/3. So here, let's do it in red. Here's a 2/3 of a quarter. There's a 2/3 of a quarter. Here's a 2/3 of a quarter. And if you divide this again, there's another 2/3 of a quarter. And then notice if you divide this again, there's another 2/3 of a quarter. There's another 2/3 of a quarter. So you've got 1, 2, 3, 4, 5, 6. So that's 1/6. And that's how you can think about reducing. And that takes us to our next question, in which we're going to reduce. These were only here so you understand what really happens when you multiply. Now, notice that, generally speaking, you're really multiplying the numerators together and you're multiplying the denominators together. Because when you multiply the denominators together, you get the size of each piece, and then you need to know how many pieces, and that's the top part. So again, the numerator, 1 times 1 is 1, 2 times 4 is 8. 2 times 1 is 2, 3 times 4 is 12. So that's all you have to do in multiplication without mixed numbers. Let's go and do one now. Here's a multiplication of two fractions. You have 5 times 18 is 90, and 6 times 35 is 210. Now, if you wanted to, you could write an in-between step, and you would have that equal to 5 times 18 in the numerator and 6 times 35 in the denominator. Notice it's just written all as one fraction, and then you multiply and you get that. You don't need to do that, and I encourage you not to, but it's just so that you understand what's going on. I'm going to be using this in a minute to show you something else as well. Now, you know this is equal to 90 over 210. Then you have to reduce. Well, by reducing, we've talked about reducing. So basically, 90 divided by, you can divide both the numerator and the denominator by 30. And of course, when you divide by 30 over 30, that's the same as multiplying by 1. And so you end up with 90 divided by 30 is 3. 210 divided by 30 is 7. So you've got 3 over 7. Now, let's go to the next one. And this one, instead of multiplying these numbers first, what I've done is I've actually prime factored. So it's, you know, when you were dividing out and when you were reducing before, when you did addition and subtraction and you needed to do that last step, all you did was find out what prime numbers could divide into each. Well, now all you have to do is prime factor each of these numbers, and then you can start canceling. But first, prime factor 154, you get 2 times 7 times 11, and 663 is 3 times 13 times 17. Notice I've written them all in the numerator, just like if you were up there, but now we're just representing as prime factors. Don't go through that in-between step again. And then again here, you've got the prime factor times these prime factors. Then from there, all you have to do is cancel out. And canceling out means that you find out whether there's a 2 in the numerator and the denominator, then they can cancel or they divide out. So there's only a 2 in the numerator, none in the denominator. We can't divide out the 2. The 7, oh look, there's a 7 divided by 7. So 7 goes into 7 once and goes into 7 once. Notice I put this 1 up here because at the end, if everything divides out, it still is 1. It's not a 0. There is a 1, all right? This one doesn't work like that, but there are some cases where it does. 11, there's an 11. A 3, there's a 3. 13, and there's no 17 in the denominator. So you're left with 2 times 17 in the numerator, which is 34. And you've got 5 times 5, which is 25 times 7. That's 175. So as a review, very quickly, when you've got rationals without mixed numbers, so there's no integer number in front, you just have to multiply the numerators together, multiply the denominators together. The easiest way to do that is multiply the prime factors of the numerators together and the prime factors of the denominators together. You divide out and you get your final answer. And that's reduced form because you've already done the prime factors.